looking at there?
Mm-hmm. Yes.
Okay. So let's review the principle here. There's a very important principle. Angle theta is equal to what in my picture?
Theta? AB, or arc AB minus arc CB, or 1/2 times.
I always like putting the 1/2 first. That way I never forget it.
Yeah, it makes sense. Just our teacher usually just does it divided by 2.
Well, I know. Most teachers do. The problem is I encounter too many students that forget to divide it by 2. Whereas if they put the 1/2 first, takes away that possible problem. Now, this equation works even if one of these lines is a tangent line. In other words, if my arc went like this, then my 2 arcs that are intercepted are still AB, but now BC is the little one. In other words, in this drawing, theta would be 1/2 AB minus CB. Right?
Mm-hmm.
Okay. And even the problem in our picture is 2 tangent lines. Doesn't change anything. We still have that angle, and we still have, excuse me, boy, my allergies are going crazy today.
It's very windy out. That's probably why.
No, I was trying to figure out why. Because I took a Claritin, but it's like I didn't take one.
That's how it went for me this weekend. I was taking Claritin morning and night, and I was still having allergies.
Yeah. So, anyway, even if you have 2 tangent lines, you still create 2 arcs that are intercepted. AB is the big one, always. CB is the little one. In other words, the one on the outside of the ice cream cone is the big arc. So, let's look at problem number 4. Give me an equation that I can write.
1/2 times 12x plus 3 minus 5x equals 75.
Yeah. For some reason, I always want to start from the left. And the reason that is actually is because when you look in your geometry books, it's always written like that.
Okay.
It's always this angle is equal to 1/2 of the difference of the big arc minus the little arc. So when I'm solving it, even if they give me this angle, that's what I'm going to write first. And then I'm just going to set up an equation and solve the equation. Let's do just a little algebra review. First step.
Times both sides by 2 to get rid of the 1/2.
Was it? Now what?
Combine like terms, so that way you have 7x plus 3.
Now what?
Subtract the 3. Divide by 7, and you get 21.
That's it. All right, let's go to another one here. Is this on your homework?
I think this might have been last night's homework.
Well, this is a weird problem for them to give you.
Yeah, this wasn't on the quiz that we took today, but
Okay.
the teacher took it off because she thought it was too complicated.
Well, it is a little complicated, but on the other hand, it's a little simple.
Right. You take the inverse tangent of theta, which is
Very
the
good.
angle
Very
attached
good.
to the center
In
point.
other words, you're going to need some trig to solve this triangle. First of all, what's the hypotenuse of this right triangle?
Hypotenuse is unknown.
No.
Or it's 10. 10.
Yeah, always remember all radiuses are the same. So if
Okay.
8 is a radius, then it's 8 from there to there plus 2, so that's 10. What kind of triangle is that?
Right triangle.
Special kind of right triangle. What kind of special right triangle?
3.5.
Yeah. Now, here's the thing about a 3, 4, 5. I'm going to change it to 3, 4, 5 just to make the numbers easier. In terms of calculating the angles, it doesn't matter whether it's 3, 4, 5 or 6, 8, 10. The angles are based on ratios. Now, what you almost never learn is what these angles are in a 3, 4, 5 triangle. These angles aren't particularly important. So you can work with literally hundreds of 3, 4, 5 right triangles and never know what this angle x is. How did you say to get x?
Take the inverse tangent of theta.
What?
Of the angle attached to the center point of the circle.
No. In other words,
So it would be 6 over 8.
yeah, or 3 over 4.
3 over 4.
Right, so we're taking the inverse tangent of that, and that solves for x. Well, it turns out that that's this number written here. It's almost 37. If you put this into your calculator, you'll get 30.
That wouldn't solve for x. That would just give you the value to subtract from 180 to get x.
Correct, exactly. You're right. That doesn't solve for x. It solves for this angle here, but that's a central angle, right?
Mm-hmm.
So whatever this central angle is the same as this little arc right there.
Yep.
So that's a 36 or 37 degree arc, and we can tell that x is 180 minus that number. Because the arc from here all the way to there is a semicircle, which is 180 by definition.
Mm-hmm.
And so this is actually the easier way to do the problem, which is to figure out this central angle, which gives you this little arc, and then you can get that little arc.
Mm-hmm.
However, in keeping with the nature of the geometry we're studying here, I'm just going to round this off, excuse me. I'm going to call that 37. This 53. Now look at the 53 degree angle in the context of our picture. What's 53 equal to? What two arcs are being intercepted?
2 arcs?
Yeah. Notice that we're intercepting the outside arc is x. The inside arc is this little angle right here.
Okay, so you're
intercepting. Whenever you have these two lines, whether they're two tangent lines or two secant lines or whatever, when they intersect outside of the circle, they always intercept two arcs. And the formula for that angle is what? 1/2.
You could do that as well.
Well, look, give it to me. What is it? 1/2 of what?
1/2 of,
It's the big arc being intercepted.
the big arc is the 37 degrees.
No, look at this picture.
Oh, the big arc. Oh, so
the big arc is x. In other words, first of all, you have to continue that all the way to the other side of the circle.
Okay.
So we're talking about the arc that is intercepted by that little side of the triangle and by this whole diameter. And that's x. So that's the big arc. What's the little arc in terms of x?
The big arc in terms of x,
No, the little arc.
the little arc.
If the big arc is x, what's the little arc? Has to be 180 minus x.
Oh, okay.
So that's what I'm going to write in there. And now we have one equation, one unknown. We're going to solve it, and let's see if we get the same thing. 106 equals, well, when I simplify that, I get 2x minus 180. Not x squared, 2x. I have an x minus a negative x.
Oh, yep, 2x.
Which is x plus x, which is 2x. Okay? And it's negative 180, so I move the 180 to the other side. So now I have 286 equals 2x. 143 equals x. And does that make sense? Yeah, it looks like it's 143, and that's also the complement of that angle right there, or that's the supplementary of that one right there. Okay? So in the context of the material you're studying now, it almost makes sense to do it this method. Because what we're talking about is the angle that's formed by two tangent lines or two secant lines or two lines that cut a circle. That's what this lesson material is all about. So solving it the other way by solving for this little right triangle, notice that either way I had to solve for that angle. I either have to solve for that angle or that angle no matter how I do the problem. So I'm always doing inverse tangent, but you actually have a choice of being able to solve for either one, and you'll still be able to solve for x. It's probably a little easier to do it the other way, but let's see. He only sent me 2 problems. Those were them, but I got a bunch the other night that are pretty good. These look familiar?
No, they don't.
No? However, they're the same subject material. Let's look at number 6. This little arc is h. This angle is 50. How can I solve for h? What equation can I write?
Not sure, these always give me trouble.
Well, these are tough. All of the problems on this page are tough, but let's think about the nature of the problems that we're dealing with. They're all of this kind, right? In other words, we have, this one is a secant and a tangent that intersect outside the circle. Intercepts 2 arcs, correct?
Mm-hmm.
Intersects.
Oh.
Okay, so what's 50 degrees equal to?
Equal to 1/2 times h minus.
No, the big one minus the little one.
Okay, well.
For the moment, we'll just call it arc AB minus h, right?
Mm-hmm.
Okay, now let's look at arc ABC. What's the measurement of arc ABC? It's a semicircle.
Oh, so it's 180.
Okay. There's 2 pieces in that arc. There's this piece from C to B, and there's this piece from A to B. So how can I define AB in terms of h, which will allow me to solve for h? You can do this. Think about it.
180 minus h.
That's it. In other words, this arc AB has to be 180 minus h if this one is h, because we can see that this is a diameter line. That's the key. If this secant line happens to be a diameter, then you always know the size of ABC is 180. And now that's very similar to the last problem we did. Only end up with 180 minus 2h instead of 2h minus 180. I don't think we need to go through that algebra. There's a couple of other interesting problems here. You don't have any specifically that you want to get to me?
Not on me right now.
Okay.
This is the stuff we're reviewing right now, so
Right. No,
we just
I
have
figured
quiz on it, but we're reviewing it again. So.
these would be good. In fact, I almost expected you to send me the same page, just because these are so good. These are tough.
Yeah.
Let's look at number 4. They want you to solve for the measurement of arc D and angle E. I struggled over this thing for 20 minutes the first time I saw it. I could not figure out how to solve it. You know why?
Why?
See, the center of the circle has been kind of covered up?
Mm-hmm.
I didn't realize that that was a diameter line.
Oh.
In other words, that says 38 degrees, and that has almost been erased. So I didn't realize that was a diameter line. If that's a diameter line, then this arc from there around to there is 180. So what's D? I mean, it solves itself once you realize that's a diameter line. In other words, because that's 38, this is 76, right? That's another very key concept. An inscribed angle is half of the intercepted arc. Cole, you still there?
Yeah, I'm here.
Okay. So, you see why this is 76?
Mm-hmm. Yeah.
What's D?
D would be, how would you figure that out? Like,
How'd you figure 76? Or how do we figure D?
how do you figure D? Like, you know, you had to get 76. You
Because
times 38.
this is a diameter.
Oh. So you take, oh, okay.
That's why it took me so long to solve it, is because I didn't see that was a diameter until 20 minutes after I started working on the problem. Once you know that's a diameter, then you know it's 180 from there to there.
So it's 104 equals D.
Right. Now you have 76 on top, you have 104 over here, you have 97 here. The only missing one is this one down here.
You can take 180 minus 97 and then divide it by 2.
Well, you don't even need to divide it by 2. You know all three of these numbers have to add to 360. So this has to be 83.
I know, but to figure out E itself.
Then you divide it by 2. So E,
Yeah,
I'm sorry, I didn't hear that right. E is 41.5 degrees. And yeah, it's really not a difficult problem at all as long as you see that that's the diameter. Yeah, you always have to know if a line goes through the diameter. On number 6, we wouldn't have been able to solve it if we didn't see that that part of the ray goes through the middle. Okay, let's look at number 5. There's a couple of really important principles on number 5. They are, When you have a quadrilateral inscribed in a circle, what is true about the opposite angles?
They're complementary?
Supplementary.
Oh, okay, supplementary.
Always. And the reason it is, if you'll notice, is that the 76-degree angle cuts out this arc, right?
Mm-hmm.
Well, the angle opposite cuts out everything else. So the two arcs have to add to 360, which means the two angles have to add to 180. Right?
Yeah.
So this is going to be 104.
And F is going to be 90.
Right. And then once you know all four angles, you're going to be able to figure out G. Well, yeah.
How would you figure out G?
What's that?
How would you figure out G?
Okay, let's go through it. We got 3 minutes here. It's difficult to do these problems unless I'm drawing them. It's hard to talk about them. So that's 76. This is 104. This is 90, and this is 90. And this is 111, and that's all the information they've given us, and they want G. Well, no single angle intercepts G.
Oh wait, I just thought of how to solve this.
What is that arc right there?
That arc right there would be 76 by 2.
152. Once you get that arc, then G is 360 minus that number minus that number.
Okay. And you could have also just taken
On any of these problems where you can't figure out how to solve for a variable, solve for something you can figure out. And then maybe it'll kind of hit you, in other words, if I can solve for one of those arcs based on one of those angles, it might leave the only thing left is G, and that's the case. All right, Cole, I'm going to let you go. Next Monday, same time?
Yep, same time.
Okay, talk to you then.
Talk to you then.